Chapter 8. In Chapter 8, our sole purpose is to explore quadratic functions, their equations, and all of their key properties. We're going to do a lot of graphing in Chapter 8. However, we're going to try to do most of our graphing without using the graphing calculator. So up until this point in algebra, we've taken a look at linear equations or linear functions, and we've noticed that their graphs are just the graphs of straight lines. In the last chapter, we took a look at exponential equations that took on the form of a times b to the x. And those were quite a bit different than linear functions. We had either exponential growth or exponential decay. Well, in this unit, we're going to take a look at quadratic equations. And quadratic equations take on the form of y equals ax squared plus bx plus c. And the graphs of quadratics are going to be in this U-shaped form known as a parabola. So let's jump in with Chapter 8.1. We're today just going to look at the graph of y equals ax squared. So first of all, a quadratic function takes on the standard form of y equals ax squared plus bx plus c, just like what we wrote up above. However, today our only goal is to look at that first term known as the quadratic term and what a does to the graph of that quadratic. All right, the vertex of our quadratic is the lowest point on a parabola that opens up, or it's the highest point on a parabola that opens down. The axis of symmetry is the vertical line that passes through the vertex and divides the parabola into two symmetric parts. All right, before we get going, it's important for us to understand the parent function of a quadratic, and that's the form y equals x squared. So it's the bare bones basic quadratic function. The domain of this is all reals. The range is all reals greater than or equal to 0. The vertex is the origin, 0, 0, and the axis of symmetry is the y-axis. And it takes on the equation of x equals 0. Remember, that's the vertical line. So you can see all of these properties over here on the right-hand side. This is the graph of y equals x squared. And this is the parent function, or the parent quadratic function. And it's going to be what we compare all of our other quadratic functions to. So here you can see it passes through the point 0, 0. That's the lowest point on this parabola that opens up. And then it goes to the point 1, 1, and then 2, 4. Those are going to be important points to remember and as we do our comparisons. All right, there's our vertex 0, 0. You can see that it's symmetric about this vertical line, and remember we called that the axis of symmetry. All right, so let's just do a little bit of comparison with a couple of other quadratic functions by trying to find some of their key characteristics. This first one here in example A asks us to start off by finding our vertex. Well, that's this coordinate right here, 2 over and 4 down, and that's the lowest point on this parabola that opens up. Our axis of symmetry is that vertical line, and that vertical line, or that axis of symmetry, is always going to pass through the vertex, and it takes on the form of x equals whatever the x coordinate is of our vertex. The domain is still going to be all reals. Our range is going to be all reals. This time it's going to be greater than or equal to -4, because that's our lowest point. Our decreasing intervals. Now remember, decreasing means when the y values are going down. And so that's for all my x's that are less than 2. My increasing interval is going to be when all my y's are getting are growing, are increasing. And that's going to be for all x's greater than 2. My x-intercepts are found here at 0, 0 and 4, 0. And then our y-intercept, where it crosses through that y-axis, looks like it's also at 0, 0, the origin. Our positive intervals, remember positive means where it's above the x-axis. So that's going to be all the x's to the left of 0. So we'll say all x's that are less than 0. And all of our x's that are greater than 4, so anything to the right of 4. Our negative intervals are where it's below the x-axis, that's between 0 and 4. So we'll say all of our x's that are greater than 0 and less than 4. And then finally our end behavior. As x approaches positive infinity, what's happening to y? Well, because this parabola is opening up, we can see that it's going towards positive infinity on the y. and same thing as it gets negative. So we'll say our end behavior here is as x goes towards positive infinity, y goes towards positive infinity. And as x goes towards negative infinity, y also goes towards positive infinity. Okay, so there's another example here, example 1b, that's asking you to do exactly the same thing. So pause the video and take a few minutes to try this on your own. Then check your answers by restarting the video. That you should have come up with. Your vertex is 2, 5. Your axis of symmetry is the vertical line x equals 2, domain all reals, range all reals less than or equal to 5. Decreasing interval is where x is greater than 2. Increasing interval is where x is less than 2. Those are your x-intercepts there. Your y-intercept is 0, 3. Here's your positive interval. Now you have 2 negative intervals. And then finally, your end behavior should be y is approaching negative infinity for both of those. All right, let's get into the meat of today. What we really want to talk about today is graphing a parabola or graphing a quadratic function of the form y equals, or f of x equals a times x squared. Now notice the only thing difference here is this a. There's going to be a number in front of that x squared, and what we want to know is how does that a affect my parabola? How does it change it? All right, so there's a couple different scenarios. When a is greater than 0, here's our first scenario. A can be greater than 0, but it can be between 0 and 1. So these are fraction numbers, right? Less than 1, so like 1/2 or 1/3 or 2/5. Then the graph of f of x is going to be a vertical shrink. And it's going to be scrunched down or vertically shrunk by some factor, and that factor is going to be whatever a is. Now, when a is greater than 1, so think of a number like 2 or 3 or even 4.5, now we have the graph of y equals ax squared is a vertical stretch. And that's going to be a stretch, again, by a factor of whatever a is. So take a look here at example 2. We want you to describe that transformation in each of these pictures. You can see on my video that I have a black one and then I have a blue one. Well, the black one is my parent function. There it is, y equals x squared. And you can see the blue one on the inside is y equals 4x squared. So it is vertically stretched. In other words, here my a value is 4. So this is a vertical stretch by a factor of 4. Now you can see what happens to the point, right? On our black parabola here, our black function, our parent function, here's the point 1 over and 1 up. It gets stretched vertically along that y-axis, the vertical axis, up 4 units. So it lands at the point now 1 over and 4 up. So this a value of 4 helps me find the point 1 over from my vertex. Notice that my vertex did not change at all here. It's still at 0, 0. All right, let's look at example B. Again, I have the graph of my parent function in black. There's y equals x squared. It goes through the origin, and then negative 1, 1, negative 2, 4, 1 over, 1 up, 2 over, and 4 up. And now I have the graph of y equals 1/4 x squared. So my a value here is 1/4. This is going to be a vertical shrink. Okay, so you can see it kind of gets squished vertically along that y-axis, and it's going to be scrunched or shrunk up by a factor of 1/4. So again, you can see that on our parent function, the point 2 over and 4 up now gets plotted at 2 over and 1 up. That y-coordinate of 4 got reduced by 1/4, and it's now here at 2 over and 1 up. All right, so that's what we have when we have an a value that's positive. Let's take a look at what happens when our a value is negative. All right, in other words, it is less than 0. So once again, a can be between 0 and negative 1. So those would be values like negative 1/2, negative 2/3, so on and so forth. This is going to be a vertical shrink again. However, it's also going to be a vertical shrink with a reflection over the x-axis. Now, our next one here is when a is less than negative 1. So think negative 2, negative 3, negative 4.5. This is now going to be a vertical stretch, and it's going to also come along with a reflection over that x-axis. So similarly to the previous one, we're going to do a couple of examples. We've got describe each transformation below. In black, I have my parent function of y equals x squared. And the blue is my transformed. This one here, my a value is -3. So there is a reflection. You can see now that it opens down, that parabola opens down. That's a reflection over the x-axis, and it is a vertical stretch. Now check it out. We just said our a value was -3, right? And it's a vertical stretch by 3. This point on my parent function, 1, 1, now is reflected over that x-axis and goes to 1 over and -3 down. So that a value is going to help us find those points right next to our vertex point. All right, in example 3b, we again have to find that transformation. Here is the graph of my parent function y equals x squared, and its other function here, y equals -1/3 x squared. So you can see that there's a reflection over the x-axis, and there is a vertical shrink. That vertical shrink is coming by a factor of 1/3. So once again, you can see all of these points, all these y values on our parent function are cut into thirds. So this point here goes to 1 over and -1/3. And this point is 2 over and -4/3. All right, one last problem to wrap up our notes for today. We got the diagram shows a cross-section of a parabolic mirror where x and y are measured in feet. Find the width and the height of that mirror. So width is just measuring from one side of that mirror to the other side. There's going to be a total distance there of 8 feet, going from -4 to +4. And the height of that mirror is going to go from its vertex up to that horizontal line that connects the edges. So that looks like that's a distance of about 1 foot. All right, that's all for your notes today. We'll see you in class tomorrow.